I could stick around and get along with you. Hello, oh, oh, oh. Doesn't really mean that I'm into you. Hello, oh, oh, oh. You're alright, but I'm your darling to enjoy the vibe. You're alright, darling to the vibe. I just came to say hello.
Ignition sequence start. The engines are on.
I was hoping that Frank Borman didn't have his hand on the abort controller. He said he took his hand off and he'd rather die than make a false abort.
1 minute after liftoff, the Saturn V is already supersonic.
Well, the Saturn V is still the most powerful machine that man has ever devised. 20 tons of fuel a second, 7.5 million pounds of thrust. 2 or 3 iffy missions before ours, but it was a piece
Engines in the first stage blast the Saturn V to 7 times the speed of sound.
The second stage cut in. Big bang.
At 40 miles high, it's still accelerating.
When you staged, you were throwing forward in the belts and then backward in the belts.
And I thought I was being...
Show that the stage is burning perfectly.
The third stage fires twice. First, the boost into orbit. The second burn takes the crew of Apollo 8.
The Big Bang.
Containing only a vast cloud of hydrogen gas.
The journey from nothing but a cloud of hydrogen to the building blocks of life is extraordinary. The calcium in my bones, the oxygen we breathe, where did it come from? It all began at the time the universe gave birth to the stars. For millions of years, the entire universe was nothing but the single vast cloud of hydrogen gas created in the Big Bang. This from the Big Bang were echoing through the cloud, making it billow and swirl. Huge whirlpools of hydrogen formed, sucking in more and more of the cloud that created them, spinning them tighter and faster to form huge balls of gas. And as they span, these enormous spheres got hotter and hotter until the stars were born.
Being able to come to that incredible release of energy associated with the violent birth of a star is with a bomb, the hydrogen bomb or the super bomb. Hell, at its very top, a small payload containing the most explosive device ever created by mankind.
The amount of hydrogen gas in an H-bomb is tiny. It's barely enough to fill a party balloon. But the energy it can unleash, this is the same energy which keeps the stars alight. All this is from just a single balloonful of hydrogen. The ball of hydrogen that makes a star is 1 million kilometers across. A star releases the energy of millions of H-bombs every second.
Inside stars, hydrogen fuses to form helium, which fuses to form carbon, then nitrogen, then oxygen, silicon, iron. So that as I look around me here, everything I see was once inside of a star. Every atom came from inside of a star.
And the stars created the elements we need for life. Oxygen in the air, calcium in our bones. This is a star that died billions of years ago. The star has run out of hydrogen fuel. The nuclear fires that have kept it burning for millions of years have gone out. As it cools, it shrinks. It starts to collapse under its own weight. It crashes inwards and explodes. The whole event is over in 1,000th of a second. They call it a supernova. An explosion so bright it outshines entire galaxies. billions of tons of star stuff hurtle outwards into space. So look at a supernova, and you're witnessing a moment of creation. But even with understand the moment of creation that happens when a star dies, you have to study the explosion.
So we really are mistimed by 2 nanoseconds.
Yes, we are.
Paul Drake's job is to recreate the most
The building right next to us, or the room right next to us, is the size of a football field. It's huge. The energy in that laser beam is 20 times the amount of electrical energy flowing throughout the entire United States at any one time.
The target is a tiny tube containing the same materials you'd find at the heart of a star.
When the laser hits this target, that creates a shock wave that's so strong that it shreds the material inside that tube. It tears the atoms apart.
Inside the tiny target is Paul Drake's version of a star just before it explodes. Last remnants of the gases that once fueled the star, mostly hydrogen. Deeper, there are layers of calcium, sulfur, carbon, and at its heart, a dense core of molten iron. Drake's tiny target is packed with these same layers. It's like a slice through a star. His aim is to see what happens when a star explodes. Here, slowed down millions of times, is what his experiment reveals. The complex patterns of an exploding star shown in astonishing detail. The beautiful and precise motions that scatter the building blocks of life out into space.
That explosion of the star throws the elements that were formed in the star outwards. They go outwards into the galaxy, and some of them gather together and form other stars, solar systems, even planets like the Earth.
These images, captured by our most powerful telescopes, show the remains of these violent events. Vast clouds of star stuff expanding through space, one of the most breathtaking sights in the universe. But there's a puzzle in these pictures. It may be the stuff of life, but these are just clouds. What could turn a cloud into rocks or water? What could turn a cloud into light?
Supernova once every 100 years or so in a galaxy, so you're pretty lucky if you get to see one in your own lifetime.
In 1987, the astronomers' dedication finally paid off. For the first time, they actually saw the moment of destruction, a star exploding, a supernova, in a nearby galaxy.
This is supernova 1987A, and we can see all kinds of parts of this exploding star. The heavy elements, the new elements that could make a new planet someday, are in this little dot down in the center. That's the actual new stuff. And then, over tens of thousands of years, that shrapnel from the exploding supernova gets mixed in with the gas in the gas between the stars. And that becomes the stuff which contracts under gravity to become new stars, new solar systems, new...
Thousands of years, countless supernovas spread and mingle. And this is what they become. Immense clouds made from ancient hydrogen gas mixed with the remains of long-dead stars. It's a stellar nursery, a place where new stars and new planets are born.
It's like this that our solar system was born.